Welcome back. The same topic, numerical sequence, exercise 5. So we have a sequence un is equal to this, and then the first one, show that un is convergent and determine its limit. How do we solve this? I know it's boring, but we gotta do it. So the first one, let me write un first. So un is equal to this. K equals 1, okay, to n 1 over n square plus k. In other words, we can write this as n square plus 1 plus 1 over n square plus 2 plus 1 over n square plus 3 plus plus 1 over n square plus n. Wow. Okay, we get it. Okay, now we have this, and then we gotta prove that it's convergent. But before we prove, I'm gonna explain a few things first. So I'm gonna write here un one more time is equal to 1 over n square plus 1 plus 1 over n square plus 2 plus plus 1 over n square plus n. And I'll do something not magic but strange. So I'm gonna write this and this here. So how many terms I have? This is the question for you. Yes, for you. 1, 2, 3, 4, n terms and fractions we have. And then so instead of this all n fractions, they're different, right? Because the first one is n squared plus 1, the second one is n squared plus 2. I'm gonna write what is the biggest one? What is the biggest one? This is, I'm gonna write, you don't have to write it on the final paper worksheet. So here this is minimum. You might ask why, because the denominator is the smallest one, so it's the maximum. The denominator is the biggest one, so it's the minimum. So instead of all n fractions, I'm gonna write the maximum one, n times n squared plus 1 plus 1 over n squared plus 1 plus boom 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 plus 1 over n squared plus 1. And on this side, I'm gonna write the minimum one n times. So 1 over, oh, you can't see it, n squared plus 1. Okay, now you can see it. Okay, this one is here. I'm writing it here because I want you to see it. Okay, I'm gonna write from here. 1 over n squared plus n plus 1 over n squared plus n plus etc. plus 1 over n squared plus n. So un is more than this and less than this. And you might be wondering why. Okay, let me explain. So here I'll be explaining you. This is just explanation part in here, explanation part. So imagine we have this fractions, 8 fractions, 4 fractions, 1 over 8, 1 over 9, 1 over 10, 1 over 11. And I'm writing this one and this thing. I mean, this side is getting bigger and this side is less. What is the minimum, maximum? Okay, this is my green pen. So this is maximum again, and this is minimum. And look, I have 4 fractions, and instead of all four fractions, I'm gonna write the maximum one on the right side. So it's 1 over 8, 1 over 8, 1 over 8, 1 over 8. That's the reason why this right side is bigger than this one. But in here, I'm gonna write the minimum one 4 times. 1 over 11, 1 over 11, 1 over 11, 1 over 11. So it's minimum one. Did you get it? So it's the same thing we did here. We have n fractions, and then maximum one is this one because this is the biggest one. And I wrote the biggest one n times. And here, the minimum one n times. You can write like this, n times. And yeah, that's the same thing we did here. If you understand this now, Just do 5 push-ups and then watch the video again, and then you will understand. Okay, now let's continue. So from here to here, how many fractions I have? N. So it's n times 1 over n square plus n. So equal to, so this is the middle is like un, less than or equal to this one, n times 1 over n square plus 1, because how many fractions we have? N. And now let's do the cancellation part. 1 over n plus 1 un less than or equal to n divided by n square plus 1. So this was the first step, and then the next step is quite easy. So we can write like this. So for all n, this is correct. And now based on squeeze theorem, I don't like this, but we can use it here. Based on this theorem, like we have 1 over n plus 1 approaches the 0, and n divided by n square plus 1 goes to 0. Based on this too, we can decide that un is convergent, and its limit of un, of course n goes to plus infinity, it's 0. So this squeeze theorem, we already learned this. I'm not going to explain this in this video because it's a long story, and you can just use this and you will get full point, I'm sure, 100% sure. And then so this is the first part, so the answer is 0. Okay, and then I'm gonna open the next page. Cool. So now we have un is less than or equal to, okay, I'm using this one, the previous page, n divided by n square plus 1, and more than 1 over n plus 1. And now the second question is, you gotta show nun is convergent and determine its limit. It's the same thing, so we just multiply by n, so n divided by n plus 1 over n un less than or equal to n square divided by n square plus 1. Okay, and now in here again we use the squeeze theorem, so it's number 2, squeeze theorem. So based on n over n plus 1, you can write this 1 over 1 plus 1 over n, this goes to 1, and this one n square divided by n square plus 1, which is 1 over n square. I didn't do any measuring, I just divided by n, and I just divided by n square. You gotta understand this, it's easy. And from this, based on this, we can decide that nun is CV. CV means convergent. I don't want to write it. Convergent. And limit. What is limit? Yes, it's 1. And approaches plus infinity. It's 1. So okay, that's it. I'll see you on the next video. Official ending. Bye bye.